Gotcha. Boyfriend drama. Sound like it. All right. I knew it was. All right. So this is example 5. I think we went over 4 yesterday, so go to write example 5 now. Graph g of x equals 2 times the absolute value of x and the parent function. So this is example 5. Go ahead and draw a little x and y axis. Graph g of x equals the absolute value of 2 times the absolute value of x. So we're going to graph that. We're going to graph two functions like we did yesterday. But now we got a different kind of transformation. We have a coefficient now being multiplied by absolute value of x. Does anybody recall who would like to make my day and just make me very happy by telling me what kind of transformation this would be? Vertical stretch? Gracias. You made my day. Okay, so it's a vertical stretch. So we know the parent function of an absolute value function is this. Okay, we should memorize this by now. It's just a v, right? Going through 1, 1, 2, 2, and so on. This is an absolute value function. I recommend you just start memorizing them at this point. If you weren't here yesterday, you might want to watch the video of my lecture about this, okay, if you're lost at this point. But absolute value, you should know how to graph it quickly. Linear, quickly. Quadratic, quickly. Constant, quickly. It's got to be like memorized by now. If not, work on that. So there's a parent function. F of x equals absolute value of x. There's your parent. The parent's going to have the child. The child is right here. And like Flora said, it's going to be a vertical stretch. Okay, but where exactly will the coordinates be if it's going to be a vertical stretch? See, for vertical stretch, we can't just move every point like one up or one down like we did with right, it closes in, so we need to get some more exact points. In other words, yesterday's transformation when we're like sliding it to the right or to the left or up and down, those are easy. We just take each point and go up how many units or left how many units and so on. But if we're going to do a stretch, we have to make a very small table of values. Just a few points just so we know exactly how that thing's kind of looking. So what I'm going to do is I'm just going to make a little table of values just to see what the stretch is going to look like. This way I have a more accurate portrayal of the new child graph, the child, not the parent. So look what I'm going to do. I know still 0, 0 is still a point. If you replace x with 0, it'll be 2 times 0, which is 0. Okay, I know that's definitely there. Well, let's see how it stretches now. Let's try 1. If x is 1, let's see. So let's see, I'm going to bring it down here. If x is 1, it'll be 2 times the absolute value of 1. Absolute value of 1 is 1, so it'll be 2 times 1, so it'll be 2. So 1, 2. How about if x is negative 1? Same thing, huh? Let me just verify just for the sake of those who are. So let me replace x with negative 1. 2 times the absolute value of negative 1. That'll be 2 times 1, which is just 2. So negative 1, 2. So we have the stretch. So look what I'm going to do now. It's going to be a slope of up 2 and over 1. I can go up 2 over 1 also right here. Up 2 over 1. And then you can see the stretch. So here's my child function now. So once we have some points, we can just use the same slope. Rise 2, left 1, rise 2, right 1. So to get to the next point is rise 2, right 1, rise 2, left 1. You can keep doing that forever and ever and get as many points as you want. But the point right now for vertical stretches and vertical shrinks, you want to make a small table of values just to get an idea of how much it's stretching and how much it's shrinking. So it's a little different than the slides, the shifts, like we did yesterday. You want to make a small table of values. All right. That's example 5. Questions? So vertical stretch, what took place? We stretched it, so it's coming up like this way. That means every point on the child graph is farther away from the x-axis than the parent. That's another way to see a vertical stretch. Every point is farther away from the x-axis than the parent. The parent's in black, the child is in blue. Talk to me. Yes. Well, okay, the black one, that's just a parent function. That's this equation. The blue is, well, I know 0, 0 is part of it, because if x is 0, then 2 times 0 is 0, so that's one coordinate. And I just made some coordinates. I replaced x with 1, and then found out what y was. Are you asking about these dots? Right, the black one's from yesterday. So this is just a parent function that we have to memorize. Up by 1, yeah. It's just up 1, right 1, up 1, right 1, yeah. Right. That we have to memorize, the parent functions. Let's try another one. Example 6. 1/2 x squared. So example 6, we're going to do the same thing. We're going to graph h of x, 1/2 x squared, and parent. So we're going to graph that and the parent. Graph h of x and the parent. This is number 6. Well, yeah, because exactly. So you can compare it. The parent of a quadratic you should have memorized also. Okay? The parent of a quadratic, it's 0, 0, then 1, 1, negative 1, 1, and then negative 2, 4, and positive 2, 4. And it comes down like this, and it goes back up. That's the parent. Right. It's not V, it's a U. It's like a U. It's a curve. Right. Active value is exactly a V. Quadratic is curved. It's different. Parents in black right now. Okay. In all these examples. So f of x equals x squared. There's your parent. Parents can have a child. Child looks like what's in blue here. The child is h of x. H of x equals 1/2 x squared. Someone besides Flores, what kind of transformation is this? Shift to the right, shift to the left, shift up, shift down. Reflection. Vertical stretch. Close. You're on the right track. Vertical shrink. It's going to be smashed. Why is this going to be smashed and the one we did isn't smashed? Because 1/2, right? It's between 0 and 1. The coefficient here is between 0 and 1, so it's going to be stretched this way. So we're going to have something like this. Okay? The u is going to be closer to the x-axis, so it's going to come up, or it's going to open up more, is what I should say. So let's make a little simple table of values here. X, Y. Okay. x is 0, that'd be 1/2 times 0, y is 0. Cool. Let me plot that point. If x is 1, let's see, it'll be 1/2 times 1 to the second power. That's going to be 1/2 times 1. Anything times 1 is itself. It'll just be 1/2, right? So if x is 1, y is going to be 1/2. What about if x is -1? Let's see. See, I'm making just a simple table of values so I can figure out how this graph is going to look, the child. If x is -1, let's see, 1/2 times -1 to the second power. Right, it still becomes 1/2, huh? Because this becomes +1, so 1/2 times +1 is still 1/2. Very good, it's the same value. And it should be because it's a parabola. So, 1/2 is right here. Look at that. -1, 1/2. And you can start seeing how it's going to be opening up. It's going to be smashed, the parabola, which means it's opening up. It's opening this way. So let's try another point. Let's try 2.
So you erased the number?
Well, I just erased them because I'm running out of room here. Yeah. Right, because notice the parabola itself, there's some values on the negative side and on the positive side. So you can get an idea of how it's going to behave, right?
Try -2 and 2.
Right. -2 and 2. So let's see, -2 and 2. 1/2 times -2 to the second power. -2 to the second power, remember we do the exponents before we multiply. Close, careful now.
4.
+4, huh? Negative times negative is +4. 4 times 1/2 is really 4 over 1 times 1/2, which is really 4 divided by 2. Just 2.
So that means that regularly the 2's, like the next one is 2, so the answer is 2.
Exactly. And that's what I think someone was saying here, yeah. It's going to be the same thing with positive. Whatever the positive value for the input is and the negative value, it's going to be the same value for y. So it's going to be 2 also. We don't have to. It's just a way to help you so you can see the behavior. Because once you make the graph, if it starts crisscrossing into here, then you're doing it wrong. So -2, 2. +2, 2. So look at, you get a better idea about the behavior. It's opening up here. It's a vertical shrink. Vertical shrink, points are getting closer and closer to the x-axis. Good. All right. Any questions so far? All right. Next one is 3/2 x. X squared, yeah. So give me another x and y axis. This would be number 7. G of x equals 3/2 x squared. So graph that and parent. On this one, I'm going to be strategic when I make my table of values. I'm going to pick values that'll get rid of that 2 to get rid of the fraction. Definitely quadratic, a second power. Tell them it's quadratic, Castro, whoever you're texting. All right, we go. Parent time. 1, 1, -1, 1. 2, 4, -2, 4. Three halves. Is 3/2. That's a strange coefficient. Is that greater than 1, 3/2? Or is it in between 0 and 1 as a fraction? It's greater. It's really 1.5. In other words, this is really 2 goes in 3 once, and then 1 left over for 2. This is really 1.5x squared. This and this mean the same thing, right? Mixed number versus improper fraction. So this is not going to be a vertical shrink. This is going to be a vertical stretch because the coefficient is more than 1. It's greater than 1. In other words, on our notes, when we summarized all the transformations, there we are. When we summarize the transformations, this is key right here. You got to know what this notation means. If the coefficient of x squared is greater than 0 and less than 1, that's a fraction in between 0 and 1, we got to shrink. If it's greater than 1, we got to stretch. So this is going to be a stretch because it's greater than 1. It's 1.5. So let's make a table of values. Okay, 0, 0 obviously is 1. That's cool. Notice how I'm going to be strategic now. Question over here? I'm going to be strategic in my values of x that I pick. I'm not going to use this form. I'm going to use 3/2 because I'm dealing with fractions, so I need to pick values of x that will cancel out the 2. So I'm going to deal with this form, not the 1.5, because 1.5 you can't multiply by a fraction. You have to change it to an improper fraction. So I use this form of the equation. So look at the values of x. To make my life easy, I want to pick values of x that will cancel out the 2. So I'm going to pick 2, -2. I'm going to pick 4 and -4. Whenever students are whispering, I'm thinking that there's something I'm missing or I'm misunderstanding here. Or?
So,
Gotcha. Question?
basically, doing numbers that are greater than.
I'm picking numbers that when I replace x with, the 2 will cancel out, so I'll have whole numbers. Because when you multiply a fraction times another fraction, you can cross cancel. So I'm picking multiples of 2 here. It'll make life very easy. Watch. Check it out. All right, here's the work here. So 0, 0 we already got. How about 2? So 3/2 times 2 to the second power is 3/2 times 4. But look at 4 over 1. Here's the strategy. 4 and 2, they cancel out. Notice. 2 goes into 2 once and then into 4 twice. So it's really 3 times 2. It's 6. So 2, 6. Welcome, Ms. Laura. We already know the negative value is going to be the exact same output, right? That's the nature of the parabola. So this is definitely 6. Let's try 4 now. Will it be 8? You might be right. Let's see. I don't trust myself. I'm going to do it. So let's see. 3/2 times, let's see, 4 to the second. So it's going to be 3/2 times 16 over 1, right? So here's a cross canceling now. 1, and then 2 goes into 16, 8. 8 times 3, 24. Way up there, right? All right, 8 times 3. Okay, so let's do it. We're not going to graph it because it's going to be way off the charts, but at least we know what the stretch is kind of looking like, right? So 2, 6. 2, 6 is right here. Oops. 2, 6. -2, 6. And then -4, 24 is way off the charts, but here's a stretch. Look, you can tell it's a stretch because it's skinnier than the parent function, which is what we should expect if we're multiplying it by a factor, a coefficient greater than 1. We should expect that. It's a stretch. Okay? Skinnier. 3 is enough for today. Grab your computers. Take about a minute if you're a social media fiend. If you need to look at your